This is Gail Kovac with Gresham Barlow School District, Summer School High School Credit Recovery, Geometry and Learning Target number 13. I can solve for missing angle measures of right triangles using trigonometry. So we just used trigonometry to find missing side lengths of right triangles when the Pythagorean theorem can't help you anymore because you've only got one out of the three sides given and you're looking for another, then that a squared, b squared, c squared thing is not going to help out. Trigonometry, however, is very useful when you know one of the angle measures to find a missing side length, because we have the ratios of sine, cosine, and tangent, which relates the side lengths to each other given a reference angle. So that is sine relates the opposite side to the hypotenuse of the reference angle. Cosine is adjacent, or the next to, over the hypotenuse, and then tangent is opposite over adjacent, or in other words, SOHCAHTOA, to help you remember. Now, in this case, instead of looking for side lengths, we want to find an angle measure. Now, notice here that I do have 2 out of the 3 side lengths of a right triangle. So in this case, if I wanted to use the Pythagorean theorem to solve for the missing third side, I wouldn't need trigonometry at all. I could just use the Pythagorean theorem and it would give it to me. However, that's not what I'm looking for. I'm looking for the missing angle measure. So I want to know what this reference angle is. Now, what I do have are 2 sides. From those 2 sides, I can find a ratio. And if I have a ratio of the sides, I can use my chart to look up what angle that is. So here's my reference angle right here. Let's see what 2 sides I've been given. I have this 21 right next to it over here. So this is the side length that is next to or adjacent to my reference angle. I also have the other leg of the right triangle. It is the side length that is across from my reference angle. This 9 here is your opposite side. My third side is my hypotenuse. That is not given to me, nor am I trying to find it, so I don't even care about it. What I care about is a relationship between the adjacent and the opposite side. So I need to figure out which ratio, sine, cosine, or tangent, am I going to use? Which one is a relationship between the opposite and adjacent sides? I'm looking for O and A, O and A. Ah, here it is. Tangent is the one that I'm going to be using. So tangent is, sorry, I meant to do this in a different color. Tangent is the ratio of the opposite over the adjacent. So that's the one that I'm going to be using. So let's see here now. I don't know my reference angle. That's what I'm looking for. So it's the tangent ratio for some angle. I don't know what angle. I don't know what degrees. That will be equal to my opposite, which is 9, over my adjacent, which is 21. So I am now going to approximate 9 divided by 21 as a decimal, and then I'm going to look up what degree measure that has to be in the chart. So my tangent of some angle measure, I'm not sure, is going to be, let's see, 9 divided by 21. 9 divided by 21 is 0 point, and I'm going to do 4 decimal points here because that's what my table gives me. 4285. 4285. All right, now let me see if there is an exact degree measure that gives exactly 0.4285, or if I'm going to have to try and find as close as possible. Okay, so now let's see. Tangent. I'm going to be looking down the tangent column of my chart. And I'm going to be looking for as close to 0.4285 as I can get. All right, starting at 1 degrees, that's 0.0175. Yeah, that's not even close. I see my ratios are getting bigger as I go down. I want to get to 0.4285. All right, I'm at 17 degrees and it's 0.3057. That's closer. I want 4285. Ooh, I've got pretty darned close, not exact. But if you look at 23 degrees down the tangent column, you get 0.4245. That's as close as I can get. For 22 degrees, it's 0.4040. That's far away. And for 24 degrees, it says 0.44. So the closest I can get, I'm going to be approximating here, is a 23 degrees. So the tangent of 23 degrees is equal to 0.4245. 4245. And that is really, really close. That's as close as we can get. So we're going to approximate this missing angle measure here at about 23 degrees, about 23 degrees. It's going to be a little bit off from that, but hey, it's pretty darn close. So that angle measure needs to be about 23 degrees because that is the tangent ratio that's really close to the one that I calculated. Let's try it for the next triangle over here. Again, I've got 2 side lengths and I'm not looking for the third one, so forget Pythagorean theorem. I need the angle measure, this one right here. This is my reference angle in the bottom left corner here. I got to figure out what this is. Now, I need a ratio that compares 2 out of the 3 of the sides. It looks like in this case, I have my opposite side. This is the leg of the triangle that does not touch the reference angle. It is across from it. So here's my opposite, 40. And then let's see, I don't have my adjacent this time. It looks like I've got the hypotenuse. So this long crooked distance here that is across from the 90-degree angle, it's the largest side of a right triangle, that is your hypotenuse. So here's the hypotenuse at 42. So now I need to figure out which trigonometric ratio of sides I am going to be using. Which one is a relationship between hypotenuse and opposite. Hypotenuse and opposite. Aha, it's sine, opposite, and hypotenuse. So sine is the relationship between the opposite over the hypotenuse. And lucky me, I know what both of those values are, so I can use that ratio to look up on my table what angle measure that is. So here we're going to be using sine. So sine of, I don't know how many degrees, that's my unknown, will be opposite over hypotenuse. All right, my opposite is 40 and my hypotenuse is 42. Now using those two numbers, I can divide one by the other to find out what that is approximated as a decimal and then just look up the angle. So the sine of something will be equal to, let's see what we get here, 40 divided by 42, top divided by bottom. 0.9523. 0.9523. All right, so I have the ratio. Now I need to look up the angle. And I'm going to be looking this time under the first column for sine. I want to try and get as close to 0.9523 as I can get under the sine column and find out what angle that is. All right, so we'll just start at 1 degrees. Oh, wow, that's way off. That's only 0.0175. That's nowhere close to 0.95. So I'm going to have to go way down. I'm just going to even start on that second part of the chart there. See, sine of 46 degrees is 0.71. Okay, so we're getting closer. And let me keep going down. All right, I see 0.8387 at 57 degrees. I got to keep going here. Ooh, 0.8988 at 64 degrees. That's getting closer. I'm looking for 0.9523, 9523, 9523. Ooh, on my chart, I see a couple of 0.95s. At 72 degrees, I see 0.9511. And at 73 degrees, I see 0.9563. I've got to figure out which one of those two is closer to 0.9523. Well, let me just look at those back two digits. I'm looking for 23. I can either choose 11 or 63. Which one's closer? Well, yeah, 11 is going to be a lot closer. Therefore, 72 degrees is going to be a much better approximation for the angle measure than 73 degrees, as I'm looking for this right there. All right, so the sine column approximates 72 degrees at 0.9511. And that is really close. So we're going to go with 72 degrees. Now, really, it's going to be like 72.4 degrees or something like that, but we're just going to go to the nearest whole degree to make things a lot more easy. So therefore, my missing angle measure must be about 72 degrees to the nearest whole degree. And yeah, I think that makes sense, right? 72 degrees, that's quite a wide angle, so that would make sense. This is going to be a lot smaller than that. So for finding the missing angle measures, this is when you're using the table going backwards to look up which angle measure gave you the ratio that you were able to pull from the triangle, given that two of those sides are going to be given to you. And again, the most important part is to figure out, are you using the sine, cosine, or tangent ratio? What two sides are you comparing? Is it sine that compares opposite and hypotenuse? Is it cosine, which compares adjacent and hypotenuse sides? Or is it tangent, which compares the opposite to the adjacent sides to that reference angle of a right triangle? Once you got that, you can either find the ratios and look up the angles, or like we did in the previous one, you can look up the ratio for a given angle and then find the missing value that way.